Welcome to another video here from Chapter 5, Discrete Probabilities. In this case, we're looking at calculating the mean and the standard deviation of a discrete probability distribution. Once again, you can print out the problem if you wish, or just look at it here on the video. Pause this if you need to do it at this time. So first of all, looking at the mean. For the particular problem here, dealing with how much time we spend on hold, study was taken, and the time on hold given in minutes with their probabilities. So first of all, the mean. It refers to all of them, so this is a population mean mu. The formula is equivalent to the formula that you had in Chapter 3. It's the sum of the x's times their probabilities. And that's multiply and add. For this particular problem, that's 0 times 0.15 plus 1 times 0.25 plus 2 times 0.4 plus 3 times 0.1 plus 4 times 0.08 plus 5 times 0.02. And with this one, there is no shortcut for data entry to find those values. In this case, that value is a 1.77 is what I'm going to use. You can use that 1.8 because that is one place value beyond the data set itself. For the standard deviation, it is again, because it's population, notation sigma. Every standard deviation will always have a square root. For this particular, or for these, it is the sum of the x's squared times their probabilities. And once again, it's square, then multiply for each particular one, minus the mean squared. So that's the formula. Then you have to make your substitution for the sum of the x's squared times their probabilities. So that requires coming off to the side and making a separate calculation. So we would do 0 squared times 0.15 plus 1 squared times 0.25 plus ... We would continue that out. We would end up with a value of 4.53. Now I can use that and substitute into the formula. 4.53 minus my mean squared, which was the 1.77 quantity squared. And again, make sure you use your parentheses correctly. That you take the square root of that whole calculation. Don't take the square root and then do the minus and the square. That gives you a final value there of a 1.18 for your standard deviation. So that's the mean and the standard deviation of a discrete distribution. I do want to make a couple notes. When you're asked for an expected value, or an expectation. Recognize that it is in fact asking for a value. So when you're looking at those, there typically is some sort of value. It's monetary or it's points or something like that. This has the notation E. It also has the notation E of x as a function, but it's the same as the mean. The sum of the x's times their probabilities. It's like the mean. So it would be the same thing as calculating the mean. It's just a special circumstance when you're dealing with values. Also, just a note, remember CVAR. Wasn't asking that question, but it is still sigma over mu times 100%. So that type of question, that value can be calculated anytime there's a distribution. If I can find the mean and a standard deviation, I can find a coefficient of variation. So that's our finding the mean and standard deviation of a discrete distribution.